The sun can shine and radiate heat all year round because nuclear fusion is constantly occurring inside it. However, its nuclear fuel will one day be completely exhausted. We know that when a massive star evolves to the final moments of its life, it will undergo an extremely violent explosion, which is what we call a supernova explosion. The electromagnetic radiation produced in this process can even illuminate an entire galaxy and also release gamma rays, X-rays, and high-energy particles, causing devastating blows to living beings in surrounding planetary systems. As early as the year 1054, the ancient Chinese astronomer Yang Weide witnessed a violent event related to a supernova. He observed a suddenly appearing bright star in the sky shining brilliantly. And because it was extremely bright, it could be seen even during the daytime. At that time, it was called the Heavenly Gate Overpowering Star and was recorded. Through modern telescope observations, it was in fact what we now know as the Crab Nebula. According to calculations, usually only stars with mass greater than 8 times that of the Sun can undergo a supernova explosion. When the nuclear fuel of a massive star is about to be depleted, it will first enter the red giant phase, rapidly expanding in size. This is equivalent to a warning sign that the star is approaching its death. After this phase ends, the entire star will explode violently because the balance of forces is broken. The energy released is equivalent to the total energy output of the Sun's entire lifetime. At the same time, it ejects a large amount of matter outward, including heavy elements created inside the star. Also, its core will collapse into a neutron star or a small black hole. If such a supernova occurs within the Milky Way, in most cases it can still be seen with the naked eye. You will notice a sudden appearance in the sky of a flickering light that lasts from several days to weeks. The matter ejected by such supernovae may eventually flow into interstellar space and under the influence of gravity form a new generation of stars. For example, our Sun is a second generation or third generation star. But for small mass yellow dwarf stars like the Sun, its fate 5 billion years later is not a supernova explosion, but the formation of a typical planetary nebula. However, Earth's position is relatively safe. Even the red supergiant Betelgeuse, which may explode at any time, is still about 640 light-years away and is not enough to pose a substantial threat to Earth. Therefore, Earth does not need to worry about the influence of distant stars for a long time to come. Moreover, we don't need to be so afraid of supernova explosions, because in fact, at the beginning of the universe, that is, not long after the Big Bang, the universe contained almost only hydrogen and helium. It was precisely because of the force of gravity that the first batch of stars gradually formed. The first generation stars were almost all cosmic giants, causing them to have shorter lifespans and to undergo supernova explosions more frequently, thereby enriching the universe with all kinds of elements. For example, the material elements that make up your body, such as the carbon needed for life, iron, and oxygen, were all produced by nuclear fusion inside stars. Therefore, it can be said, without hundreds of millions of stars constantly forming and perishing in cycles, there would not be the rich and colorful universe we see today, let alone life forms like us humans. So in the end, we too are part of the countless stars.